Welcome. Today we're going to do some curve sketching. It's not anything new, it's just the stuff we've learned from first derivatives and second derivatives all put together. So remember, when f prime was bigger than 0, that meant your function was increasing and f was going up. When f prime was less than 0, then your function is decreasing, and so your function is going down. Okay? We also know that when the second derivative is bigger than 0, then your function is concave up, so it's one of these shapes, either the full holding water shape or some part of it. And when f double prime is negative, then it's concave down, so it means it's trying to dump the water or some part of that shape. All right? And when it switches sign from positive to negative, the second derivative, that's an inflection point. All right, so really, let's do an example. So sketch the graph of f equal to 1/3 x cubed minus 1/2 x squared minus 2x plus 3. All right, so what does the shape look like? And really what we want to have is we want to have the local maxes, the local mins, the concavity, and the inflection points, if there are any, evident in the graph. Okay. All right, so we start with the first derivative. It tells us the most. So f prime is x squared minus x minus 2. So that factors as x minus 2 times x plus 1. So first of all, the zeros, f prime is 0 at x equals to -1 and at 2. Okay, so those are possible local max, local mins. All right, next we do our little chart. We know that the derivative is going to be 0 when x is -1 and when x is at 2, so derivative is 0 there. And remember, f prime is x minus 2, x plus 1, x minus 2, x plus 1, x minus 2, x plus 1. Now the x plus 1 term will be negative here, and then it'll switch to positive once we get to the right of -1. And the x minus 2 will be negative to the left here, so these two terms, and it'll switch to positive once we pass 2. So altogether, the first derivative will be positive here, negative here, and positive here. So f will be increasing here, flattens out there, decreasing here, flattens out there, and then increasing. So that's the rough sketch of f. Up, down, and you can see, of course, we have a local max at x equals to -1 and a local min at x equals to 2. But what about the concavity, and where does it switch? So for that, we need to look at the second derivative. So f double prime, let's see, to know what f prime was. So it looks like f double prime will be 2x minus 1. So I'm looking up here. All right, so f double prime is 0 at x equals to 1/2. All right, so let's take our rough sketch of f. Remember, f here was rough f. At 1 and at 2, we had this behavior. It was going up, going down, and then going up again. That was the rough sketch of f. But now we know something about the second derivative. At x equals to 1/2, well, this is where the second derivative is 0. So f double prime will be 0 here. And everywhere to the right of this, the 2x will make it positive, and everywhere to the left, f double prime will be negative. So that means on this interval here, it'll be concave down. And on this interval here, it'll be concave up. And this is 0 here, it goes from negative to minus, so this will actually be the inflection point. So that lets us take f and draw f with concavity now. So remember we had here at 1, here at a half, and here at 2. And this was the inflection point, so it was going up until here, had a local max, and then it switched concavity there, then had a local min there, and came back up. All right. So this was at x equals to minus 1, x equals to 1/2, and x equals to 2. And you see here, we have a local max there, a local min here, and this was an inflection point. And of course it was concave down here and concave up right here. So this is the sketch of f. Okay, that's it for curve sketching. See ya.